these first two practice problems, it says the perpendicular bisectors of triangle ABC intersect at point G. So perpendicular bisectors intersect at the circumcenter. So again, just trying to like put that in our brain to memory. Perpendicular bisectors intersect at the circumcenter. Also, color can help your brain like remember that stuff goes together. So like if you put perpendicular bisector and circumcenter in the same color, your brain will put those together. Okay, so perpendicular bisectors in this picture, I'm just going to highlight them. This right here is a perpendicular bisector, this one, and this here. And I can see that. The reason why I know that is because it creates a 90-degree angle with those lines right there. And then these perpendicular bisectors are equidistant from each of the corners. So this line right here, all these blue lines are equal in length. So this here, same length as this, same length as this. So if this is 9, then this is 9, and this is 9. All the blue ones are 9. And the question specifically asks for the length of BG. So looking at this, BG is one of the blue lines, so BG equals 9. Okay, and then number 2, this looks a little different. The way this is drawn, it's more like 3D. What happens is the circumcenter for this one is like outside of it. So let's see. So I'm looking for perpendicular bisectors first, and I'm going to highlight all those pink. So GD is a perpendicular bisector to this segment. And then GE is a perpendicular bisector here. And then behind GF is a perpendicular bisector. And then this here, point G, is the circumcenter. And then the circumcenter is the same distance from each vertex. So same distance from A to B to C. All the blue ones are the same length. This is the same length as this, is the same length as this. So if this blue one is 11, then this blue one is 11, and so is this one. It asks for the length of GA, so GA is 11 units. Okay, and then 3 and 4 are definitely like testing type problems, like in a testing format. It says, modeling in real life, you and 2 friends plan to walk your dogs together. You want the meeting place to be the same distance from each person's residence. Explain how you can use the diagram to locate the meeting place. Well, with these 3 points, if we were to draw a triangle, like this, the circumcenter would be the same distance from each of those points, like equidistant from each of those points. And the way we find the circumcenter is by finding where the perpendicular bisectors intersect. So I'm going to like eyeball the midpoint of each of these segments here. See this, I would say this is midpoint. I would say this is the midpoint. And then I'm going to draw a perpendicular bisector. So I'm going to draw a perpendicular line from that midpoint. And it might not be exactly perfect. I'm trying my best. And where those perpendicular bisectors intersect is the circumcenter. And that circumcenter is equidistant from each of the friends' places. So therefore, the circumcenter would, be able to tell you where to go. The meeting place. That was fun. Okay. So one more time. So number 4 right here. You open a donation center that's same distance from each of the 3 stores shown. Use a diagram to determine the location. So we need a place that's the same distance from each of these stores. So we're going to draw a triangle as best we can. Then we are going to draw perpendicular bisectors from each side. So I find the midpoint, and like the midpoint here, I'd guess is about right here, midpoint here. Draw a perpendicular line from that midpoint. So these are supposed to be like 90-degree angles. Again, I'm freehanding it, so it might not be exactly perfect, but the whole idea. And then this here would be the same distance from each of the stores. Something we will do toward the end of the year when we're reviewing this is we'll actually make constructions to find the circumcenter. So if you found the perpendicular bisector of each line, then you could find the circumcenter exactly, but we'll save that for later. Okay, now down here, we look at the numbers a little bit more. It says angle bisectors, and specifically now we're switching to angle bisectors, so I'm going to switch colors. Angle bisectors, and angle bisectors intersect at the incenter. And again, I have a chart up here to kind of help your brain to put those together. So I'm going to highlight the angle bisectors right here. Let's see. This is an angle bisector, this is an angle bisector, this is an angle bisector. And then this angle bisector is the same distance from, like the incenter here is the same distance from each of these sides. So like if this is 9, this is 9, and this is 9. And it asks for the length of PB, which I labeled as 9, so PB equals 9. And number 6, same idea. Wants to know the length of HP. Let's look at the angle bisectors first. Here's an angle bisector, here's one, and here's one. And then this incenter is the same distance from each of the sides. And it shows a little arrow saying that that's 15. So then HP would be 15 as well, and so would this. So HP equals 15. Okay, we're not going to do the whole graphing thing right now, so just cross those out. And then we'll move to the other side. Okay, and then over here, we're going to do 11 and 13. And then we're not going to do the other ones over here. So for 11, it says you have the incenter is point N. So the incenter right here is equidistant from each of these sides. So like all these pink lines are the same length. And ND is 6x minus 2. NE is 3x plus 7, and it wants you to find the length of NF, which all three of them are the same length. So if you find the length of one, you'll have the length of NF. But first, before we find that length, we have to find the value of x. Since these are the same length, we can set these equal to solve for x. So nx minus 2 equals 3x plus 7. And solve for x, subtract 3x from both sides. Plus 2, 3x equals 9. Divide by 3, x equals 3. So x equals 3, so I'm going to plug that into one of these expressions. It doesn't matter which one. Plus negative 2. 18 minus 2 is 16. ND is 16. And since ND equals NE, which equals NF, NF would then be 16 as well. Okay, write it down. 13, NK, and NK, NL, and NM all come from the incenter. They are all the same length. So we're going to do the same thing. We're going to set these equal to solve for x, and then plug the x back in to find the length of NF. So 2x minus 2, draw a line, equals negative x plus 10. Aiden, wake up. Aiden, rise and shine. No? Okay. Do your work. Okay. Plus x, 3x minus 2 equals 10. Plus 2, 3x equals 12. Divide by 3, x equals 4. Then, once we have x, we can plug it into any one of these expressions. Nk equals 2x minus 2, so I'll do 2 times 4 minus 2, 8 minus 2, nk equals 6. Great. Since nk equals nl, which equals nm, that means nm equals 6 as well. And we're done. Okay, so you guys have a lot of time to do your homework, so take your time. Grab a laptop. Please let me know if you have questions. When you're done with the homework, please jump on to Alex so you can get some of that done as well today. I'm going to pause the video here.